Hi everyone. So in this video, we're going to look at how exponential relationships can be modeled using graphs and how we can find the equation of an exponential model from a straight line graph. So if we take a look at this example, we're told that the relationship between two variables is modeled by this equation. And this is a classic exponential equation, but we're going to look at what it actually means. We have y equals ab to the x. The y and the x are the variables, and the a and the b are the constants. Here, the a is the initial value when x equals 0, and b is the growth or the decay factor. So if b is greater than 1, the values will grow, and if b is less than 1, the values will shrink. So now if we focus on this graph, in this case, the data has been transformed by taking logarithms. So we've taken the logs of both sides of this model, and we've plotted log y against x. That's the key idea here. So if we take the log of both sides of this equation, then we have the log of y will equal the log of ab to the power of x. And then we can use the multiplication rule of logs to split this up. So we'll get the log of y will equal the log of a plus the log of b to the power of x. And then we can use the power rule to bring this down. And I'm going to write this term first. So the log of y will be x log b plus the log of a. And this looks just like the equation of a straight line graph, where we've got y will equal mx plus c. The log of y will map onto the y term, which you can see on the vertical axis. The x's will match up, and m, the gradient of that line, will be the log b term. So we can say that m, the gradient of our straight line, will be equal to the log of the constant b. And then we can see that the intercept c will map onto the log a term. So c will equal log a. And you can see in the question that we're given the gradient of this straight line. This is 0.045. So 0.045 will equal the log of b. Then we can work out the b term by raising 10 to the power of both sides. So 10 to the power of 0.045, these two will cancel, will equal b. And when we work this out, we get b to be approximately 1.11. So this will be our growth factor. And then to find the a term, well, we're given our intercept as 0.0221. That's this value here. So the intercept will equal the log of a. And again, if we raise 10 to the power of both sides, these two will cancel. So we'll get 10 to the power of 0.221 will equal a. And this works out as approximately 1.66. So the model that best fits this data is y is equal to the a, 1.66, multiplied by b to the power of x. Okay? Well, that was a simple exponential model, and all we needed was a straight line graph of log y against x. In the next question, we're going to look at a different exponential model. So now we're told that a scientist studies the growth of a particular species of plant in a controlled environment. She measures the height y of several plants at various ages, and after coding the data by taking logarithms, she finds a linear relationship represented by this regression equation. Given that the relationship between the height and the age can be modeled with this exponential equation, we need to work out the values of a and the values of n. So do you want to give this question a go? You can start by taking logs of both sides of this exponential model. Okay, so welcome back if you had a go. So we know y is equal to ax to the n. If we take the logs of both sides, then the log of y will be the log of ax to the n. And then we can split this up using the multiplication rule. So the log of y will be the log of a plus the log of x to the n. And again, I'm going to make this the first term and use the power rule to bring this n down. So the log of y will equal n log x plus log a. And if we map this onto the equation of a straight line graph, then y will equal mx plus c. And we've been given the gradient m as 0.6. And the intercept c is 0.1761. So now if we map this to this equation, the log x term will map with the x term, so n will be m. So this will be our constant n. N will equal 0.6. And then the constant term will map to our log a term. So the log a will equal 0.1761. We can cancel out the log by taking 10 to the x of both sides. These will go, so a will be 10 to the power of 0.1761. We can work this out and we get approximately 1.5. So our exponential model, y will equal a multiplied by the x term to the power of n, which is 0.6. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.